Hello and welcome back to the second part of today's speedrun, which is about lines, planes, and angles. And so now we're focusing on angles, so let's jump right in. So we need to know how to find three angles. The first one is the angle between two planes. I can't draw a plane, okay. Say we have two planes like this, we need to be able to find the angle here. And this angle is always acute. And we can do that by actually just getting the angle between their normal vectors, which we can do using the scalar product. And we just need to make sure that we're finding the acute angle, since we might get an obtuse angle between the normal vectors, and we just need to convert that to an acute angle. The same goes for two lines. The angle between two lines is the scalar product, and we always have to find the acute angle, not the obtuse one. So we might have to, again, figure out, go 180 minus the angle. And finally, the angle between a line and a plane, we get by getting 90 minus the angle between the normal and the line. Because if we get the angle between the normal and the line, and then we subtract 90, we can get the angle between the line and the plane. So that's how we'll solve that. So with those three cases covered, let's jump into some questions. So the first one is planes 3x plus y minus 2z is equal to -1, and x minus 4y plus 2z is equal to 3 are given, so we need to find the equation of the line of intersection and determine the angle between the two planes. Okay, find the equation of the line of intersection. How are we going to do that? So we can start off with x is equal to 3 plus 4y minus 2z. So we have 3 times 3 plus 4y minus 2z plus y minus 2z is equal to -1. So we have 9 plus 12y minus 6z plus y minus 2z is equal to -1. So we have 13y minus 8z is equal to -10. Okay. So knowing this, we can then say that 13y is equal to 8z minus 10, and then substitute back into the original equation. So if we have x is equal to this, actually we need to use lambda somewhere. We need to substitute lambda into this equation. So we should have said x is equal to lambda. Let's go back. Sorry about that. So we have x is equal to lambda, just a real number. So we have 3 lambda plus y minus 2z is equal to -1, and lambda minus 4y plus 2z is equal to 3, and we just need to express y and z in terms of lambda. So we have y is equal to -1 plus 2z over 3 lambda. So we have lambda minus 4 times that is plus 2z. Wait. Checking myself up. Can we just subtract them? Oh yeah, we can just add them. Hold on. So we add these two together, and so we get 4 lambda minus 3y is equal to 2. So we get y is equal to How did they get what? I don't understand this book. Why? They wrote it wrong. So this should be y is equal to, let's see. Y is equal to, because we have 4y, so we have y is equal to 2 minus 4 lambda over 3. Negative 2 actually, minus. Oh, but plus. Okay, interesting actually. Never mind, I'm wrong. Y is equal to 4 lambda minus 2 over 3. And then z is therefore equal to, this is going to be 13 lambda minus 6z is equal to negative 4. So negative 4 plus 3. So z is equal to 1 plus 13 lambda over 6. So that's the equation of the line. So next, we can say like x is equal to lambda, y is equal to 4 lambda minus 2 over negative 3 over 3. And z is equal to 13 lambda plus 1 over 6. So this is the parametric equation of the line. And then next, we need to find the angle between the two planes. And so we can get the angle between these two planes by getting their normal vectors and finding the angle between that. So we know the normal vector of this one is 3, 1, negative 2, and this one is 1, negative 4, and 2. So what we can do is we can simply get the A1, B1, in other words, the dot product. So we have 3 minus 4 divided by AB cosine O. So this is equal to cosine theta. And so we have the square root of 3 times 1 plus 2. 9 plus 1 plus 4 times the square root of 1 plus 16 plus 4. So this is equal to negative 5 over 9 plus 1 plus 4, 4 square root 14 times square root 21. So we have negative 5 over square root 294 is equal to cosine theta. So we have theta is equal to 5 divided by square root, answer, cosine, inverse cosine, that is equal to 1.27 radians. Is that correct? Yeah, around 1.27 radians. So that is the correct answer. It's the angle between two planes. Finally, we have the question, the line x minus 2 is equal to 1 minus y over 3 is equal to z minus 2 over 2, and the plane 3x plus 2y minus z equals 1 are given, so we need to find the point of intersection and determine the angle between the line and the plane. So we can find the point of intersection by expressing this all in terms of x. So we have, we need to express y in terms of x, so we have 3x minus 6 is equal to 1 minus y, so we have x minus 7 is equal to negative y, so y is equal to 7 minus 3x. So we have 3x plus 2 times 7 minus 3x minus z is equal to, expressed in terms of x, 2x minus 4 is equal to z minus 2, 2x minus 2 is equal to z. So minus 2x minus 2 is equal to 1. So now solve for x, 3x plus 14 minus 6x minus 2x plus 4 is plus 2 is equal to 1. So we have 3 minus 8, negative 5x is equal to 14 plus 2, this is negative 15. So x is equal to 3. So we have x is equal to 3, and then we can plug it into here. So 1 is equal to 1 minus y over 3, so y is equal to negative 2. And z is equal to 4. Yeah, so this should be the correct answer. Just check if that's correct. Yeah, 3, negative 2, 4. And then finally, find angle between the line and the plane. So I would prefer to, can we rewrite this? Or can we at least get the direction? Because we know the normal vector here is equal to 3 to negative 1. So we need to get the vector of this. So we get x is equal to lambda plus 2. Y is equal to 3 lambda negative 3 lambda plus minus 1. Y plus 1, no, plus 1. So y minus 1 over negative 3. Yeah. And z is equal to 2 lambda plus 2. So therefore we get this entire line is just 2, 1, 2 plus lambda times 1, negative 3, 2. So we need to find the angle between these two. So that's equal to dot product, so 3 minus 6 minus 2 all over square root of this 132, so that's 10, 16, no, 14, square root 14. So it's actually this 3 minus 6 minus 2 over 14. It's equal to cosine theta. So we have 3 minus 8, negative 5 over 14 is equal to cosine theta. Theta is equal to cosine negative 1, negative 5 over 14. So this is equal to 1.93 radians, but we have to be a bit careful because that's an obtuse angle. So we have to actually subtract that from pi. So the real angle is equal to 1.20 radians. Sorry, I forgot to get the absolute value. This should be absolute value of the dot product. I forgot to cover that. So anyways, we always need to take the absolute value of this, since we always need to find the acute angle. So we actually get 5 over 14 is equal to cosine theta. So theta is equal to cosine negative 1 of 5 over 14 is equal to 1.2. What has the book done? This should be 1.21 radians. Not, they gave 0.365. And that's weird. It should be 1.21. Unless they've expressed it in terms of pi. It might be 0.365 pi. So yeah. So this answer is correct, so it's 1.21 radians. So that was all for the speedrun, and I hope to see you in the next one. See you then.